Hello everybody, today we're going to be taking a look at this problem right here. Given array nums, write a function to move all zeros to the end while maintaining the relative order of the non-zero elements. Do this in place without making a copy of the array. So here we got an input of 0, 1, 0, 3, 12. And what we're supposed to do is we're supposed to shift 1, 3, 12, the non-zero elements all to the beginning. So the first number should be 1, second number 3, 12, and then the last two numbers are just going to be put as 0. So hopefully the problem should be pretty self-explanatory. Remember, the key here is that you have to make sure that they're in the relative order. I know one tempted solution you might immediately think is, oh, why don't you just do like some type of swapping operation? Why don't you just go through the loop, swap 1 and 0, swap 0 and 0, and then keep basically swapping the elements. However, if for example there was like a number 2 here and we have the number 0 and we're trying to swap it to the first position or the last position, you might actually end up like, if you're trying to shift this 0 around to like swapping it with this number for example, that would cause the order to be reversed. So we need to make sure that the relative order is maintained. And also what we need to make sure to do is to do this in place. So another solution you might think of is like thinking, oh, why don't we just make an array and then an additional array, make an additional array in which we put all the elements. So let's say 1, 3, 12, we'd loop through the list, put in 1, 3, 12, and then at the end go and put each of the remaining zeros. However, the problem is we cannot use a separate array because we are meant to do it in place, so we're not allowed to make a copy of the array. That is a key element that we need to make sure. Now, let's start by making the function def move zeros of nums. So how we're going to be doing this is similar to what we were doing. We want to first keep track of the non-zero elements, so we're going to be making not one but two iterations in the loop. There is a way to do it through one iteration. However, doing it in one iteration would mean we'd need to make a copy of the array, add in each of the elements 1, 3, 12, and then fill the remaining gaps with 0. But we would need an additional array to do that. In order to do it in place, we would have to make two separate loops. So we're going to have a first position value that we're going to be iterating through. Next, for the first loop, we're going to say for I in range of nums. What we're essentially going to be doing here is we're just going to gather all the non-zero elements. So how are we going to do that? We just say if nums of I, so if the index is not equal to 0, then what we're going to be doing is we're going to be shifting that element to the first position. So nums of pos is equal to nums of I. So it's that simple. So we get this first, for example, in this first value, it's 0, so it doesn't go into this condition. However, this number, it does go into the first condition. So we move this one to 1, and then this one doesn't, and then at the end of this loop, we're just going to be incrementing pos, because we want to shift the position value to 1. So for example, this one goes to here, and then we shift the position value to the 1, so we're trying to fill in the second spot. We look for a non-zero element. Here's the non-zero element, so we shift that one to 1, and then 12 to 3. So we got that. However, as you might notice, these two values will be unchanged. So all we need to do is, starting from the pause, which we shifted to this last element, for I in range, not the position is actually going to be the number after. So for example, here, remember how position started at 0? We added 1, then we got to 3, and then we get to 12, and then at the end of this, the position increments by 1, right? So we're starting from here, for I in range of the position, to length of nums. All we're going to be doing is setting that position to 0. So a little bit of a correction here. This isn't actually going to be iterating through the loop twice. This is only going to be, it is 2 separate loops, but essentially it is 1 loop through the entire thing, where we initially start by starting with the non-leading zeros, and then starting from this point we're going to be filling out all the remaining positions to 0. So it was a little bit of my mistake for not clarifying this earlier, but the overall time complexity is going to be n, but specifically it's going to be exactly n, not the worst case time complexity is going to be n, not 2n. So that is the best solution that we got. We can return nums, and let's test out the code. So let's print out move zeros of, let's put in the input. So we put out the input, and what we should get is hopefully an array that looks something like this. Let me see. So we got an error here. Print move zeros of. Oh, that's my bad. In this section of the code, I tried to loop through nums. It's in Python. You could say for element in nums, but when we're using the range, it has to be an integer here. So we're going to be putting length of nums here. And then when we run the code, there we go. We get the value of 1, 3, 12, 0, 0. And this will work for any larger values that we have. We can put in like a few more elements, 8, 1, 0, 0, 0, something like that. And let's put these at the beginning just so we can see like them shifting to the end. So if we get something like that, and here we see all the zeros go to the end, and the relative position of 1, 3, 12, 8, 1, they're all at the beginning. So that's exactly how the code works with zero space complexity, because it's an in-place algorithm. No additional space is really needed, and time complexity of exactly n, because we're just essentially iterating through the loop only once. So that's how you would solve this type of problem. Hopefully my explanation was clear, and yeah. See you, everybody.